First, let's start by exploring how materials data is structured across Ansys Granta Selector and how you'd be able to navigate the core functionalities of the software. So here you can see the home screen of Granta Selector, which showcases the different databases that can be available in Selector. What you probably have access to as a student team is the material universe and the jam curve data database, because these are what we call core data and are always available in the software. The other databases shown here are what databases that are add-on and can be added on top of this core data. If there is any need for your design process, you can get in touch and essentially have these databases added to the core data. Now, at the top of the screen, we have the main toolbar, which houses the core functionalities of the software. If you're interested in finding information about specific materials, applications, processes, you'd be able to use the browse and the search functionalities, and you can use chart select to create visual charts, to compare materials, and to run material selection projects. Okay, so let's start by the browse functionality within the material universe database. So let's click on browse. As you can see here, we have information for ceramics and glasses, for fibers and particulates, hybrid materials, including composites and natural materials, liquids and gases, magnetic materials, metallic alloys, and polymers. So let's imagine that we are interested in a specific composite and we want to find more information about this material. So if you go into the composites folder and go into polymer matrix, for example, we can see that there are different types of polymer matrix composites available here. Let's go into the epoxy folder. As you can see, there are different types of fibers or second phases that can be available in this composite. I'll go into carbon fiber folder and there are different options here. Let's go into the unidirectional prepeg, and there are different types of layups for this composite. So let's go into unidirectional layup, and if you double click on the label, the datasheet for this polymer matrix composite pops up, which includes information about designation of the material, trade names that you'd be able to buy this on the market, typical uses of the material, as well as a brief description of the composite. In this case, for example, we can see that the material family is composites, its base material or matrix is epoxy resin, and it can have between 65 to 70% by weight filler, essentially the fiber that is included there, which the material for the fiber is carbon, and so on. We also have information about the price of the material, its density, mechanical properties of this composite are available, including Young's modulus, yield strength, Poisson ratio. If you're interested in finding out a bit more about any of these material attributes, you can click on the information icon next to each attribute, and by doing so, a design note pops up, which helps you when you're trying to, for example, find if a material would be suitable for a specific design or application. This brief information can be helpful. If you want even further information there, you can click on the science notes, which includes comprehensive information about, in this case, Young's modulus, including how a brief description, of course, how it can be calculated or measured, the other material attributes that are relevant to Young's modulus, as well as at the bottom of the page, we have a list of further reading where you can go into any of these textbooks and find information about Young's modulus. So a self-learning tool which is available in the software. If you scroll down, you can see that we have information about the impact properties, including fracture toughness, thermal properties, including melting points, thermal conductivity, thermal expansion, electrical, magnetic, and optical properties of the material are available. Whether the material can be used in healthcare or food is mentioned. If the material might be hazardous to health or environment is mentioned here, as well as for polymers or polymer matrix composites, we have absorption and permeability information. How well the material would be able to withstand different environments, and more specifically, how well the material would be able to resist chemicals, specific chemicals. So these are, dozens and dozens of specific chemicals, and you can see, for example, for specific alcohols or acids or alkalis or oils, if the material be able to resist this specific chemical. So let's scroll down. We have information about environmental attributes. So if that is what is part of your design process, you'd be able to find embodied energy and CO2 footprint for the primary production of the material, as well as processing it with different processes. At the bottom of the page, we have end-of-life attributes, so whether the material can be recycled or not, as well as it can be put in the landfill, downcycled, and so on. At the bottom of each material datasheet, you'd be able to find links that would take you to other parts of the software that have relevant information for essentially this material. So, for example, if I click on the Process Universe link, it would take me to all the processes that are compatible for shaping and surface treating of this material matrix, polymer matrix composite. So let's open up composite forming, for example, and go to the manual layup folder. And if we click on hand layup, it would show me the data sheet that we have for this manufacturing process, which includes a brief description of the process, a schematic of it, as well as the shapes that can be created using this process, physical attributes, including the tolerance and roughness that can be expected of the parts that have been created using hand layup. We have some process characteristics as well as a cost model that would enable you to see for different batch sizes what would be the cost of creating a component using this process. The parameters used for the model are customizable, so you can essentially change these values, and the software would let you know how much it would be, how much it would cost to use this process to manufacture a part. So it's a good self-learning tool to learn about the manufacturing side of using a specific process. And at the bottom of the page, again, we have some design guidelines, technical notes, typical uses of this process, and economic and environmental notes relevant to this composite forming process. All right, so that's the typical structure of data for different materials and processes in Granta Selector, and you can find that in the Browse section. Now, if you're interested in a specific material or application or process, but are not sure how you'd be able to find that within the Browse tree structure, you can directly search for it. So if I go to search and search for a chassis, for example, you can see all the different parts of the software that have information about chassis. So let me open up the Material Universe folder, and these are the materials that mention the term chassis in their datasheet. So for example, if I go into the high strength low alloy steel, you'd be able to see that in the typical uses, chassis is mentioned, and any part of the datasheet that this term is mentioned, it is highlighted to let you know why you're looking at this datasheet when you search for a specific term. Okay, so The third functionality and the final one that I'm going to talk about at this point is the chart select. So this is what you'd be able to use to create visual charts and run material selection projects. For the material selection projects, I'm going to leave that for the case study that we have for today, which is material selection for chassis. I'm going to create a visual chart to show you how that can be done within Granta Selector. So let's click on chart index. And so the first thing that we need to identify here is what is it that we are trying to visualize. So if you go into the select from, there are different databases and data tables that are available in the software. I'm interested in looking into and visualizing all the materials that are available within the material universe database. So I'm going to click on that data table. And you can see that we have 4,224 materials available in this data table. So in order to create a chart, we can click on chart index. The software asks us to fill in the y-axis and the x-axis. In this case, I'm interested in creating a chart with single material attributes for each axis. For example, on the y-axis, I'm going to put the mechanical property of yield strength. So I'm going to choose mechanical property as the category, and as attribute, I can find yield strength at the bottom of the drop-down menu. You have the choice to use logarithmic or linear axes. I'm going to stick to logarithmic. And for the x-axis, I'm going to put the physical property of density. So physical property as category and density as my attribute. And when you click on OK, the visual chart pops up with which you'd be able to compare all the materials available in this database. So you have the option to essentially label each of these bubbles, which is dedicated to a material available in the database by clicking and dragging. You can see that on the top right corner, we have osmium, commercial purity, and on the bottom left corner, we have melamine foam. So we can easily visualize and compare these materials in terms of their strength and density. You can also visualize the material categories. So if you click on show family envelopes, you can see the families of materials that are available here. And again, you can click and drag to label these material families. So as you can see, we have metals and alloys here, fibers and particulates, non-technical ceramics, mineralized tissues, foams, and so on. Okay, so very briefly of how you'd be able to create a visual chart. And now let's move on to our material selection case study for a chassis.